So in case of the, why efficient way? Suppose you have a huge amount of coal, okay? You have a huge amount of coal, and you are getting just a small amount of work. Is it feasible? Is it feasible to be in mechanical engineer? No, it's not feasible. Why? Because our target, if I have a huge amount of coal, then burning of this, I will get the work, okay? Then our target will be what? How I can warm the coal so that I can obtain the maximum possible work by the burning of this coal, okay? So the aim of thermodynamics is to convert heat into work by the efficient manner or efficient way. One more thing, suppose you are driving your bike, okay, and you are giving 1 liter of petrol, and just your vehicles go to 2 or 3 kilometers. Is it feasible? What happened in your IC engine or your bike? What is going to happen actually? Actually, what's happened when you put the fuel, there is a burning, okay, by the chemical reaction in the fuel, due to which burning takes place, and due to which what you will get the heat. You will what get the heat, and after that, when you attain the heat, you have to target to convert this heat into work, okay? So what you have to apply the different process by which the burning should occurs, so that you can get the maximum amount of work. Therefore, it's not feasible to us that you are purchase a bag and giving the petrol of 1 liter and just mileage is 2 to 3 kilometers. It is not feasible. And if I'm engineer, that's obviously it's our target, that how to optimize our work, how to optimize our work from the burning of the fuel. So this is the aim of thermodynamics, to convert heat into work, okay? And hopefully I know you guys are well aware about the basic definition, like the system, surrounding, boundary, that all are very basic things. So I am not interested to deal all of that, okay? So no, for short introduction, I can say what is system. Something upon which you have focus, you have to study. This is your system, okay? And what is what is surrounding? What is surrounding? What is surrounding? Just wait. What is surrounding? Then I want to tell you is, sometimes what's happened, a student is going to give the definition, everything external to the system is surrounding. That is wrong definition, okay? So be careful here. Everything external to the system is not a surrounding, okay? So you have to put focus here. You can say everything external to the system till which the effect of system can be felt, the effect of system can be feel. So this is called surrounding. But sometimes what's happened, a student used to say everything external to the surrounding, everything external to the system is surrounding. That is not a proper definition. No, suppose I am speaking here, I am a system. That means if I am speaking here, then what is the effect of this thing in the America? Is there any effect? No. So it is not our surrounding. Only surrounding is those things in which the effect of system can be feel. Effect of system can be feel. Suppose this is our system, okay? Suppose this is our what? Our system. And let's say their temperature is 100 degrees Celsius. So this whole screen is not the surrounding. Only a small area in which the effect of the system can be felt. The temperature of the system of this can be felt in this zone. So this only zone is the surrounding, not whole screen is the surrounding, my dear friends. One more thing, what is boundary? Boundary is used to separate the system and surrounding. And a boundary can be real, boundary can be imaginary, and boundary can be real, boundary can be imaginary, and boundary can be flexible also. So this all points about the what, system, surrounding, and boundary, okay? They are actually two property of a system, okay, now. So first thing is that, what is, if I will ask, what is your property, what is the property? So you have to keep in mind, if I will ask what is the property, then you have to now sound is clear now. I think sound will be cleared, okay? Please let me know sound is clear. Hopefully sound will be clear there. Is it okay? Okay. So what is okay. So tell me what is a property? What do you understand by property? If I will ask what is property? Okay, what is property? So your answer should be, generally a student tells any characteristics of the system is called property. This is general definition given by the student. That is absolutely wrong answer. What a student used to say, everything, sorry, any characteristics of system is their property. That is exactly wrong definition. Okay, my dear friends. So what is the property? Now try to understand one thing. If you give the example, if you give the definition of the property, everything extra, what is property? Characteristics of the system, all the characteristics of the system is property. Then tell me one thing, my dear friends. If I will ask, what is the color of this pen? What is the color of this pen? Yes, your answer will be, sir, it is black. Okay. Now I will ask, how much black it is? How much black it is? Then what will be answer? Yes, you can say, sir, black color is their characteristics. Yes, it's okay. But now my question is that, how much black it is? Then what will you answer? You can't say. Same thing. You use the body spray, okay? You use what? Body spray. And I will ask, how much small is this? You can say, yes, sir, this is smell is good. Now my question is that, how much smell is good? Can you measure? Can you measure the smell? Can you measure the smell? No. Third thing, by the help of taste, you can also, taste is also the characteristics of the system. Okay. Suppose I have given you an apple and I will ask, what is the taste of apple? Then you can say, yes, sir, it is sweet. Or, yes, sir, it is sweet. Now, my question is that, how much sweet it is? How much sweet? Someone will say, sir, it's too much of sweet. Someone will say, sir, yes, it's okay. This is only sweet. Now, tell me one thing. What is the unit of sweet? Can you measure the sweetness in our engineering? No. So, my dear friends, from today onwards, what you have to tell? What you have to tell, my dear friends? You have to tell only those characteristics of a system is property which can be measured. If the thing which cannot measure can't be property of a system or engineering property, yes, this is their property, but not an engineering property. Okay. So this thing you have to keep in mind. Okay. The characteristics which can be measured of a system is their property. So three things you can't measure. You know what? You can't measure taste, you can't measure smell, you can't measure color. So these three are not a property. Okay, you can measure the temperature, you can measure the pressure, you can measure the volume, you can measure the mass. So this, you can measure the enthalpy, you can measure the entropy. Think that you can measure, that all are property. Hopefully this thing is cleared. Okay. So, my dear friends, this is basic definition. There are two types. One is entropy. Sorry, there are two property. One is extensive, and another one is what? Intensive. Okay. And one more thing, property is always what? Point dependent. Okay, it depends on the point only. Okay. So now take some question. See, heat and work are. Heat and work are. Option A, intensive property. Option B, extensive property. Option C, point function, and option D, path function. What should be answer? If you have attended my session, then obviously you are well aware that heat and work are always of path function. Heat and work are always a path function. It is not a property. Okay. If not property, then I can't talk about the what? About the intensive or extensive. Okay. So the answer is what? Path function. Heat and work are is what? Path function. Why? Because it's okay. Now tell me one thing. Why property is a point function? Why property is point function? Can you say why property is point function? Suppose I am making a PV diagram. Okay. This is our what? PV diagram. Okay. So so see, can you say at this point some pressure will be P1? Suppose this one, someone is P1, and this volume will be P1. Okay. As point will change, property will change. Okay. Now if I talk at this point, then yes, again volume will change, and pressure will change. Okay, so this is called what? Point function. Property is called what? Point function. Why? Because property will going to vary with point to point, therefore it is what? Point function. But if you talk about the path function, okay, so what will happen in the path function? It not depends upon the point. Okay, it's not depends upon the point. Suppose this is point 1 and this is point, suppose this is 1, this is 2. See here, this is point 1, this is point 2. One from point 1 to point 2, they are infinite way, there are infinite way we can reach from point 1 to point 2. Okay, but the value, if I will talk, suppose p2 minus p1, then it is constant. If I will talk, suppose this is v2, so if I will ask v2 minus v1, then it is constant. Doesn't matter how you are going to reach at this point, they're infinite way. Okay, but the value will be same, p2 minus p1. Why? Because it's only depends on the point, no depends upon the path. But tell me here, this is what our PV diagram. Okay, yes, you have infinite way, you can reach like that, you can reach like that, you can reach like that. Okay, but if you talk about heat and work, so heat and work is what? It's not going to depends on the point only. If suppose if you are going to follow this path, suppose if you are going to follow this path, just wait. Okay, then we will say, sir, this one, this area will give work transfer. Okay, because why? You know now, if you talk another path, this path, then only this area. If you talk this path, then only this area. So what is going to happen? It is going to depends on the path, therefore it is called what? Path function, not a point function. Okay, hopefully this thing is clear. Now take this question. An isolated thermodynamic system execute a process. Choose the correct statement from the following. You know, in GATE 2021, GATE 2021 MSQ, multi-select question is going to ask. Okay, MSQ, multi-select question is going to ask. So I have framed some question on MSQ, multi-select question. So what should be answer of this? An isolated thermodynamic system execute a process. Choose the correct statement from the following. Option A, no heat is transferred. Option B, no work is done. Option C, no mass flow across the boundary of the system. Option D, no chemical reaction can take place within the system. Then what should be the answer of this system? What should be the answer of this particular question? See, if you talk about the isolated, okay, so isolated system means what? In isolated system, no heat is going to transfer. In isolated system, no work is going to done or no work is going to transfer. Okay, and if you talk about the C, so no mass flow across the boundary of the system. Yes, this one is also right. So if this is MSQ question, multi-select question, then answer should be what? A, B, C. Now question is that why sir D is wrong answer? Why D is not a correct answer? No chemical reaction takes place within the system. What? Within the system. This is what? System. Why this is wrong? Okay. So here this point is due to this no, this whole statement is wrong. Okay, suppose this is our insulated isolated system. Okay, if isolated system is there, that means what? No mass transfer is going to take place, no heat place, no work transfer is going to take place. Suppose if there are two different substances and chemical reaction is going to take place, yes, it may be endothermic, it may be exothermic, but what will happen? All things will be inside, not going to outside. Chemical reaction is going to take place that will not disturb the isolated condition of isolated system. If it is going to happen, no, my point, no problem is there. Therefore, this no chemical reaction, it is not a necessary point. It is not a necessary. If chemical reaction is going to take place, it's also isolated system, because chemical reaction can be two types. Either it will be endothermic or either it will be exothermic. In one case it will absorb the energy, in another case it will release the energy, but whatever they will do inside the system only. Whatever they will do, that will be done inside the system only. Therefore this point is wrong. So correct answer is what? A, B, C. So such kinds of question you can expect in this year in multi-select question. Okay, now see, which one of the following statement are true with respect to heat and work? And again, this is MSQ question, multi-select question. So what should be the answer? What should be the answer? Which one of the following statement are true with respect to heat and work? First one is they are boundary phenomena. Okay, they are what? Boundary phenomena. They are exact differential. They are path function. So what is the answer? Now what is generally a student going to get confused or going to ask, sir, what is the meaning of boundary phenomena? What is the meaning of exact differential? What is the physical meaning of inexact differential? What is the physical meaning of exact differential? So in such kinds of problem, students are going to ask us, what is exact differential? What is? Try to understand. Try to understand this one, my dear friends. Now, try to understand this one. Suppose this one is P and PV diagram, okay? Suppose this 2 point is there, just let point 1 and this one is what? Point 2. This one is what? Point 2. Now, if I will ask, what will be delta P? So we can say, sir, P2 minus P1. If if you can write delta P equal to P2 minus P1, directly differentiate, direct difference you can write. So this is called what? Exact differential. This is called what? Exact differential. Exact differential means what? If I will ask what is delta V, you can say yes sir, V2 minus V1. Directly you can write. Therefore it is called what? Exact differential. That is the why property is called what? Exact differential. But now my dear friends, tell me, tell me, this is our PV diagram. Okay. So this is point 1, this is point 2. 1, you are going by following this path. Okay. And then this is 1, this is 2. Then what will be work done in this case? This area will give work done. Okay. Now, another possibility is that, you are going through this path. Okay. Now, what will be work done? This area inside the red color will give work transfer. Now, if I will ask, what is about dw? What is about dw? So can you say directly w2? Can you say w2 minus w1? No, because end point is same, 1 and 2 is same, but you can't say dw is w2 minus w1, because in this case, in black color case, the value will be different. In red color case, the value will be different. Therefore it is called that work transfer is inexact differential. You can't say dw equal to dw2 minus w. You can't say. If you suppose, if you are choose another path, then this value will be something different. Therefore it is called what? An exact differential. Okay, are you getting this point? So it is called what? An exact differential. Whenever I use an exact, then I used to write like that. Okay, so I used to like dw. Similarly, you can write dq. Why? This is notation to show the inexact. So yes, that means they are exact differential. No, heat and true with respect to heat and work. Heat and work both are inexact, not exact. So statement second is wrong. They are path function. Yes, this is right. And first point, they are boundary phenomena. Yes, this one is also right. So what will be the correct answer? First and third is the correct. Okay. So can you understand why they are boundary phenomena? Energy, work and heat and work can be said only when if energy is going to transfer from the boundary. Okay, if energy is going to transfer from the boundary, only such case you can say work is going to transfer or heat is going to transfer. If they will not cross the boundary, not heat and work is going to happen here. Suppose I am telling you one example. Suppose I am telling you example. Suppose this one. Okay. Suppose this one is our system and energy is there. Energy is there. Okay. If this energy is not going to transfer, if this energy is not going to transfer the boundary, then I can say there is no heat or work transfer. There is no heat or work transfer. If this energy will cross the boundary, if this energy will cross the boundary, only such case we can say work or heat, whatever, is transferred here. Therefore, it is called as boundary phenomena. Why? Because they have to transfer the boundary. Therefore, it is known as what? Boundary phenomena. Okay. Therefore, this is called what? Boundary phenomena. So, first and third is the correct answer. Okay. During a non-flow thermodynamics process 1 to 2 executed by a perfect gas, the heat interaction is equal to work interaction Q12 equal to W12 when the process is option A isentropic, option B polytropic, option C adiabatic, option D isothermal. So what should be the answer? My first question to all of you guys, tell me what is difference between perfect gas and ideal gas? A student is going to confuse that what is perfect gas and what is ideal gas. Can you say what is difference, or is it the same, or is it difference, or is the same? Can you say what is difference between perfect gas or ideal gas? Can you say anyone what is difference between perfect gas and ideal gas? Yes, try to understand this one, my dear friends. This is very minor difference between the perfect gas and ideal gas. Try to understand this one. Suppose in case of ideal gas, Cp and Cv is a function of temperature. This is told by Mr. Joule. This is told by Mr. Joule by experimentally that in case of ideal gas, Cp and Cv is a function of what? Temperature. Then it will be what? Ideal gas. So what is perfect gas? Suppose if Cp and Cv is no, or you can say Cp and Cv is constant, that means it is not going to vary with respect to temperature. Temperature is going to change, but there is no effect on the Cp and Cv. Then in such case, you can say that this is what? Perfect gas. What? Perfect gas. Okay. That means we can say the minor difference, that means we can say there is a minor difference, there is a minor difference between the perfect gas. Okay. Thank you, Puja Pallavi. Thanks to all of you. Okay. So in case of perfect gas, what? Cp and Cv is remain constant, they are not going to vary with respect to temperature, then gas will be perfect gas. Okay. In case of ideal gas, as temperature will change, Cp and Cv will change. So whenever you are talking about the perfect gas, it must come in your mind that Cp and Cv is constant, that are not going to vary with temperature. Okay. So this is the basic difference. Hopefully you have getting. Okay. So qw. Okay, so now tell me, option is that isentropic, polytropic, adiabatic and isothermal. No, one important key point here. What is key point? Non-flow thermodynamics. Non-flow, this is the key point here. Non-flow means what? Closed. Okay, so you know, in the, if non-flow is there, so you guys are well aware dq equal to what? Du plus dw. Are you getting why? Because of non-flow. That is, I am talking about the closed system, and for closed system you can write dq equal to du plus dw. Are you getting this point? Now it is saying it's equal to, the heat interaction is equal to work interaction. That means dq should be equal to dw. Okay, what? Dq should be equal to dw. In which case, now tell me. So if you talk about if you talk about, so what in general what is going to happen? So du should be what? Du should be what? Zero. If du will be zero, that means internal energy will be zero. In such case you can say that dq will be equal to dw. And my dear friends, only one case is there, in which case interchange in internal energy will be zero, and this is what isothermal. This is what isothermal. You guys have well aware about this point because I have discussed much more times in the class. In case of isothermal process, there is no change in internal energy. In the very detailed manner, I have discussed this thing by the proper setup, by the proper, you can say, setup in the class. I have proof that in the case of isothermal process, there is no going to change in the internal energy, my dear friends. So we can say in case of isothermal process, dq equal to what? Tw. Okay, now one very important point I want to share with all of you guys. One very important point. This point is that generally a student tells, sir, heat is low grade energy and work is high grade energy, and sir, low grade energy can be 100% completed in the work in the high grade energy. How this is going to happen? I am telling that what heat is low grade energy, work is high grade energy, and you know that complete conversion of low grade energy into high grade energy can't be possible. It can't be possible. Then how it is going to happen? How? So, my dear friends, you have to keep in mind this complete conversion of low grade energy in high grade energy not possible for a cycle, but in case of process it can happen. So what is this? This is process. Do you know what is the difference between process and cycle? You should know. Okay, suppose this is point 1, this is point 2. Okay, I am going like that, so it will be called what? Process. Okay, but suppose this one I am going that, again I am coming again, so this is called what? Cycle. So in case of conversion of low grade energy in a high grade energy, complete conversion of low grade energy in high grade energy is not possible for a cycle, but for a process it can possible. In which case? In case of isothermal case, it is possible to conversion of low grade energy into high grade energy for a process in case of isothermal process. Hopefully this thing is cleared. Okay, so at this point we can keep in mind sometimes it's happen, students say, sir, never possible. So in interview you are going to stuck in such kinds of point, but in the process it is possible, but for a cycle, for a process it is not possible. So this point you have to keep in mind. Okay, okay, my dear friends, can you take this question? What is this? A balloon containing an ideal gas is initially kept in an evacuated and insulated room. The balloon is ruptured and gas fills up the entire room. Which one of the following statement is true at the end of above process? At the end of above process. Option A, the internal energy of the gas decreases from its initial value, but the enthalpy remains constant. Option B, the internal energy of the gas increases from its initial value, but enthalpy remains constant. Option C, both internal energy and enthalpy of gas remains constant. And option D is that both internal energy and enthalpy of gas increases. Okay, so what will be the answer of this question? What should be answer of this question? Okay, so we can understand this one. Just wait. Okay, so what should be answer of this one? The internal energy of a gas decreases but its value, but the internal energy of the gas increases from its initial value, but the enthalpy remains constant. Option C, both internal energy and enthalpy of the gas remains constant. Option D, both internal energy and enthalpy of the gas increase. Okay, so what should be answer of this question? First, tell me one thing. In initially kept in an evacuated and insulated room, okay, the balloon is ruptured and the gas fills up the entire room. Now tell me one thing, what is this process? What is this process? Is it throttling, or is it throttling, or is it free expansion? Is it throttling or is it free expansion? What do you think about this? Is it throttling or free expansion? What do you think? Try to understand this one. So suppose this question is very easy. Okay, so you can know this one is, you know, about your balloon. This is inside a room. It's evacuated and insulated room. That means room is insulated. Evacuated means there is no mass inside the room, so it is what? Insulated. The balloon is rupture and gas fills the entire room. Balloon is going to rupture, that means it is going to break a rupture, and whatever gas inside the balloon, that is going to fill the room. Okay, then which one of the following statement is what? True. Okay, now tell me one thing, my dear friends. If you talk about this, okay, then what will be work done? What will be work done? What will be work done? So this is our system. So this is our system, my dear friends, and it is insulated. Are you getting my point? It is what? Insulated. So whatever energy is going to transfer from this balloon, so it will be inside the room only. So it will be what? Inside the room only. Why? It is insulated. Not anything is going to transfer the boundary. Are you getting the point, my dear friends? Are you getting my points? Whatever, if they going to rupture, then whatever energy will release, so this will be inside this room, inside the room only, inside the room. It is not going to out. Why? Because of insulation. It is not going to out. So you can say in such case, dq equal to, you can say dq equal to 0 and dw is also equal to what? 0. Dq is 0 and dw is what? 0. One more thing I will discuss. Okay, now tell me one thing. Since it is closed system, so you can write dq equal to du plus dw. Okay, since dq is 0, dw is 0, so we can say du is what? Du is what? 0. That means we can say what? u1 equal to u2, u1 equal to u2. That means in such case internal energy will remains constant. In such case internal energy will remains constant. That is point is fixed. Are you getting point? This point is what? Fixed. Internal energy is constant. Now if you see the question, then not a single question is asking. There is a, some information given about the enthalpy also. Okay, my dear friends. So if gas, so try to understand u1 equal to u2. Now suppose if gas is ideal. Now suppose if gas is what? Ideal. Now I am assuming gas is what? Ideal. If gas is ideal, so you can write what? You can write, you can write u internal energy function of temperature. You can write now. So if du equal to 0, so we can write du is what? M cv. Okay, or you can say dt will be equal to 0, but mass can't be 0. Mass will be something. cv can't be 0. That means dt will be 0. dt will be what? 0. If dt is 0, that means t1 equal to what? T2. T1 is initial condition when there was no rupture in the balloon, and T2 is final condition when rupture has takes place in the balloon. Okay, so in this case T1 equal to what? T2. T1 equal to what? T2. Are you getting this point? T1 equal to what? T2. Okay, now again, what if you talk about the what? H enthalpy, then what is enthalpy? U plus PV. And in case of ideal gas, U is a function of temperature, and you can write like that. U PV, you can write MRT. That means this is constant for a given closed system. Mass is given. R is characteristic gas constant is constant for any particular gas. So constant closed is there. So U is a function of temperature, and this all quantity is a function of temperature. So we can say enthalpy is also function of temperature. Enthalpy is also what? Function of temperature. But my dear friends, tell me one thing is that in this case you can say the initial and final temperature is same. That means, my dear friends, initial and final enthalpy will also same. Why? Because temperature is not going to change at initial and final contention. Temperature is same, so enthalpy will be same. So enthalpy will be what? Same. So my dear friends, So my dear friends, you can see here what should be the answer. Both internal energy and enthalpy of the gas remains what? Constant. So option C is the correct answer. Someone has given option D. How you are going to think? So option C is what? Option C is the correct answer. Okay. One more thing, my dear friends, I want to tell you. Sometimes in MSQ, a student is going to stuck. Sir, here T1 equal to T2. If ideal gas, that means isothermal also. Are you getting my point? Now, here T1 equal to T2. So student is going to confuse. Sir, in this case, T1 equal to T2, that means initial and final temperature is same. That means it is isothermal also. No, my dear friends, don't make such kinds of conclusion. Okay, here initial and final temperature is same only. Initial and final temperature is same, but intermediate temperature is not same. But for a process to be isothermal, initial, final, as well as intermediate temperature must be same. But here what's happened? It is not isothermal. Why it is not isothermal? It is not isothermal because here only initial and final temperature is same, but intermediate temperature is going to vary. Are you getting this point? Intermediate temperature is going to vary, so it is not. Are you getting this point? So it is not isothermal. So they, never confuse. Okay, one more thing I want to tell you. U1 equal to U2 will be any gas. Internal energy will be equal in any gas. In any gas. But enthalpy will be constant only if gas is ideal. If gas is what? Ideal. Or gas is what? Perfect. In such case, enthalpy will be constant. Sometimes what's happened? A student is going to buy her trade. Okay, what they are going to buy her trade. If throttling is there, okay, if free expansion is there, so in this case what they are going to buy her trade, internal energy remains constant, temperature remains constant, enthalpy remains constant. Such kind of some conclusion a student is going to make in their mind, but you have to keep proper assumption also. Internal energy will be same for always. Okay, but enthalpy will be here same only when temperature will be same on temperature, enthalpy will be same only when if gas is ideal. If gas is not ideal, you can't conclude like that. Okay, so these are the some question that we can expect in your coming exam. Okay, you can expect in your coming exam. Okay, so take this question. Thank you, Guddu. Julie. A steam flow through a nozzle at a mass flow rate of m dot equal to 0.1 kg per second with the heat loss of 5 kilowatt. The enthalpy at the inlet and exit are 2500 and 2350 kilojoule per kg respectively. Assuming negligible velocity at inlet, that means C1 equal to 0, the velocity C2 of the stream in meter per second at the nodal exit is dot 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 correct to two decimal place. Okay, so this is what NAT question, numerical answer type question. So how we can solve this question? In this question, this information is given. H1 equal to 2500 kilojoule per kg. Initial velocity, that means velocity at the inlet is given, this is 0. Mass flow rate is given 0.1 kg per second. Enthalpy at the exit, that is given 2350 kilojoule per kg. Okay, and what you have to calculate, you have to calculate C2, that means velocity at the exit. Okay, and one thing is given that here heat is going to loss from the system or from the nozzle, and that's value is what? 5 kilowatt. Okay, so how we can solve this question? Just wait. So enthalpy flow through a nozzle of mass flow rate, that means, so you know, this is what? STD flow. Na? Why? Mass is going to transfer, heat is going to transfer, apply the SFEE, that means STD flow. SFEE, that means you have to apply the STD flow energy equation. What you have to apply? STD flow energy equation. Okay, so what is this one? This one is what you can say. Just wait. M, you can say M H1 plus half c1 square plus gz1 plus of q dot equal to what, m h2 plus half c2 square plus gz2 plus what, work done. Okay, so this thing, so in this question mass flow rate is given, h1 is given, h2 is given. Okay, and since this question, assuming negligible velocity at inlet c1, velocity of the steam nozzle exit, one more thing that you have to keep in mind, in case of nozzle, if you talk about the nozzle, then w of nozzle will be zero. That means work done in the case of nozzle will be what, zero. So you can say if nozzle is there, so w will be what, zero. But here heat is going to transfer, so you can write here m1 m, that means is given h1. What is the value of h1? 2500. c1 is negligible, so you can neglect. One more thing here, uh, assuming negligible velocity, and you can assume that change in potential energy is also what, negligible, because this is horizontal now, horizontal. So change in potential, that means gz1, you can say gz1 minus gz2. So this one is approximate negligible because horizontal is there, so you can neglect this one. Okay, so in general, you can say, if you make a general discussion, so you can write mh1 plus q equal to what, mh2, okay, plus half m c2 square, half m what, c2 square. So you can write what is the value of here m, 0.1. What is the value of h1? 25. What, okay, now tell me one thing here. You can say heat is going to out from the system. Okay, it is not going to inside the system, it is going to out, it is going to what, out. Okay, so you can write here in minus sign. Why? Because it is going to out. So you can write 5 equal to what, m, that means you can write 0.1 multiplied by what is the value of h2, you can say 2350 plus half zero point 0.1 plus of what, c2 square. Okay, so if you solve, then what we will get, by solving here we will get the value of c2, and this value will be 447.213 meter per second. Okay, by solving this you will get this value. Okay, one more thing I want to tell you, suppose what's happened, sometimes what's happened in the exam, h1 is given, suppose let's assume 200 kilojoule, and v1 is given 10 meter per second. Okay, and again assume h2 is given, let's assume 300, and v2 is given how much, let's assume 20 meter per second. Okay, so if you are going to apply the steady flow energy equation, so what will happen, it will be, let's assume for per kg, that means I am taking mass 1 kg, so you can write h1 plus half c1 square plus gz1 plus of q equal to what, h2 plus of half c2 square plus of gz2 plus of w. Okay, so what's happened, my dear friends, see what is the unit of h, so their unit is kilowatt. Okay, kilojoule. Okay, what, kilojoule, unit of h is what, kilojoule. But if you talk what is the unit of this velocity, what is, so are you getting a point, only meter square whatever. So what better to write, if you have not making h1 plus half c1 square multiplied by 10 to the power minus 3. Now what is going to happen, both is going to in the kilo, this one is also in the kilo, this one is also in the kilo, so we can add and no problem is there. But suppose if you are not here multiplied by 10 to the minus 3, and you are going to add, then unit is different, that means one has kilo, another has normal unit, so you are going to making a problem in the exam, and you will get the wrong answer. So my dear friends, my suggestion, whenever you are going to solve on such kinds of question, better to write 10 to the power minus 3. At the same time you can multiply, this one is also 10 to the minus 3. Okay, because this unit there, here is no also kilo, but here this will be given in the kilowatt, so no issue is there, kilojoule whatever, kilojoule will be there. So this thing will be given, so no problem will be there. So this thing you have to keep in mind in the what main exam, otherwise you will going to get the wrong answer, and mostly option A will be the answer that will you get, and this will be the wrong answer. So now can you take this question? Can you take this question? A compressed air bottle of volume 0.15 meter cube. A compressed air bottle of volume 0.15 meter cube contains air at 40 bar and 27 degrees Celsius. It is used to drive a turbine which exhausts to a atmosphere at 1 bar. If pressure in the bottle is allowed to fall to 20 bar, find the amount of work delivered by the turbine. Okay, so I think this type of question, something different, not a single time till now has been asked such kinds of question in the GATE exam. So hopefully I think in the coming exam such kinds of question can be framed, especially by the IT Mumbai. Such kinds of question you can ask. So try to understand, try to solve this question. So what is this question, my dear friends? Just to wait. A compressed air bottle of volume 0.15 meter cube contains air at 40 bar, and 27 degrees Celsius. Suppose this is your bottle. Let's assume you can write. So this thing is your bottle. Okay, this is your bottle. Okay, so in this their volume is given, you can say volume is 0.15 is given here. Pressure is highly compressed air is there, highly compressed, how much? 40 bar. That means inside the this bottle pressure is highly compressed, and this value is 40 bar, and temperature is only 27 degrees Celsius. Now it is used to drive a turbine which is exhausted to the atmosphere at 1 bar. That means by the help of this, we can say, bottle, a turbine is going to connected. Okay, by the help of this, we can say a turbine is going to connected. What is this? Suppose this is what? Turbine. This turbine is going to connected. Okay, so now question is that if the pressure of the bottle is allowed to fall 2 bar, that means whenever you are going to open the tap of the bottle, so it is highly compressed. So what will happen? Forcefully, it will move to the turbine, and it will strike the turbine blade by the very high velocity. It will strike the turbine blade. It will strike the turbine blade. As it strikes the turbine blade, then what's happened? Turbine blade start rotating. Turbine blade is what? Start rotating. If turbine blade will start rotating, that means you are going to get the rotational work. Okay, if it is going, that you means you are going to get the rotational work. So here you have to find the amount of work delivered by the turbine. That means how much amount you can get at the outlet of the turbine. So my dear friends, tell me how we can solve such kinds of question. And I think this is VVI, very very important in your exam. Okay, so first tell me what is the mass inside the bottle. Initially, what is the mass inside the bottle? So you can, you know, no? So it is air, na? So air is ideal gas. You can treat. Okay, so you can write what? PV equal to MRT. Okay, so suppose P1 V1 equal to MR T1. So you can write M1 is what? P1 V1 upon R T1. What is the P1? 40 bar. So 40 into 10 to the power 3. It will convert it into kilo. Okay, 10 to the power 2 only, not 3. What is the volume? 0.15. Yes, you have to write 0.287. What is temperature? If you will get, we will get how much? 300. So by solving this, we will get this value. So initial case, initially 6.97 kg of air is compressed inside the bottle. Okay. Now, if you talk about the second case, okay, if you talk about what? Second case. So, okay, one more thing is here given that bottle and turbine is adiabatic. This is given here. Bottle and turbine is adiabatic. This is given. Adiabatic. Batic. Okay, so you can write T2 upon T1 equal to P2 upon P1, okay, power gamma minus 1 upon what, gamma. Okay, so what is the value of, can you find here from T2? Yes, you can find. So you can write T2 upon T1. So what is the value of P2? So initial, how much pressure? Fall to 2 bar. That means pressure inside the bottle will be 2. Initially this was 40. Since fall here, so you can write 1.4 minus 1 upon 1.4. Okay, so by and T1 you have given 300. T1 is given, so you know T2 you can write 300, 2 upon 40 whole power zero point 0.4 upon 1.4. Okay, so if you solve, then you will get the value of T2. This will be 127.5, 127.5 Kelvin. That means you have get the T2. Now tell me one thing, what will be value of N2? What will be the value of mass? So you can write M2 equal to P2V upon R T2. P2V upon R T2. What is the value of P2? So you know 2 into 10 to the power 2. What is the volume? So in the same bottle 0.15. What is the value of R? 0.287. What is the value of T2? So this is 127.5. Okay. And if you solve, then we will get the value of M1. So you will get the value of M1, and this one is what? This value will be 0.82 kg. Okay. Now tell me one thing. Why I am going to calculate M1 and M2? Have you considered why I am going to calculate M1 and M2? Why it is necessary to us to calculate this one? So my dear friends, I tell you, this is the case of what unsteady flow. This is the case of what unsteady flow. And how you are going to get this, that this is the case of unsteady flow. If you have attended our session, then I have told you, whenever key point, what you have to check the key point in the question whenever you are going to filling a water. So if you are going to fill a water, that means as time passes, the property of the fluid, what is going to be changed? It will be changed. So whenever any property with which is going to change with respect to time, so it will be what? Unsteady. Filling a bottle, or you can say emptying a bottle, or another one is filling of air inside the balloon. So these all are key points through which we can understand that this is the question of the unsteady. Okay, this is the question of what? Unsteady state. So in case of unsteady state, my dear friends, if you have attended the session, then obviously you are well aware M2U2 minus of M1U1 equal to what? Minus M2 minus M1, okay, into H minus W. This thing you will get. That is the why I have here calculated M1 M and M2. Okay, now you have get the M1 and M2. Now tell me one thing, you have to calculate internal energy also you have to calculate. So how we can calculate the this internal energy? You know what is U2? You can write what? CV into T2. So what is this value? 0.718. Okay, one more thing. CPCVR. This thing we have to remember for a year. This thing you have to remember. This data will not given in the question. Okay. So you know this point 1.005. This is what? 0.718. What is this for air? 0.287 kilojoule per kg Kelvin. Okay. So this data you have to remember always. Okay. This one is also kilojoule per kg Kelvin. This one is also kilojoule per kg Kelvin. This one is also okay. So T2 in what Kelvin? So 127.5. If you get, what will be U2? So this will be, I think, 91.54 kilojoule per kg. What? Kilojoule per kg. Similarly, you can calculate U1. What is the value of U1? You can write CVT1, and if you calculate what? 0.718. What is the value of T2? So you can write 300. So you will get 215.82 kilojoule per kg Kelvin. Okay. So now in this case you have to calculate work. Okay, what you have to calculate? You have to calculate work. So first you have to calculate the enthalpy. Once you will get the enthalpy, we will get all the things. Okay, so how we can calculate H? Average enthalpy you can calculate. You know CP T. Okay, so one thing we can do, calculate H1 CPT1, calculate H2 CPT2, and final take the average. So value of H2 upon 2, this one average value you have to take here, H1 plus H2 upon 2. So better to write, you can write like that, CP you can take common, T1 plus T2 upon 2. And if you solve, then you will get this value. If you solve, then you will get this value. This value will be equal to 215.4 kilojoule per kg. Okay, kilojoule what per kg. So you have calculate H1, and you have calculated it. Or another thing we can do, calculate H1 separately, calculate H2, and then we can take the average. It's the same, you will get the same. Okay, so by solving this, we will get the value of H is what, 214.82. Okay, now what you have to do, you have to m1 u1 minus of m2 u2 equal to minus, you can write minus m2, this is what, m2 m1 u1 m2 minus what, m1 h minus of w. Okay, now just you have to put the all this value m1 m2, and after putting this value we will get the value of w, and this will be equal to 2 2747. You can write w equal to 27 2747.44 kilojoule. So we will get the answer, this one. So in you have to remember some key point. Okay, in case of an STD, how you will get, suppose whenever you are going to fill an empty vessel, empty cylinder, you have to fill the gas inside the empty cylinder, then you can understand that this question is asked by using the unstd state concept. Okay, you are going to fill a balloon. Okay, so balloon, that means you are going to fill the air. Balloon will implant, it's going to, no. So what's happened, their property will be going to change as time passes, so it will be also what, unstd. Third thing, suppose anything is going to emptying, suppose this one, that question I have discussed here, this one is bottle. Okay, this one, assume your what, bottle, and it is going to empty. So then what's happened, as time passes, the property of the fluid which is inside the bottle, their property will change. Okay, so it will be what, unstd. Why? Because if property will change with respect to time, so it will be unstd. So my dear friends, this will be what, unstd. So these three or 4 points that you can keep in mind, so you can understand which one is std or which one is what, unstd. Okay, so, my dear friends, now in the this is your fair segment. Try to solve this question. If you are going to a stuck, then let me know. In the coming session, I will discuss this question. Question is that a spherical balloon of 1 meter diameter containing a gas at 200 kilopascal and 300 Kelvin. The gas inside the balloon is heated until the pressure reaches 5 kilopascal. During process of heating, the pressure is proportional. This is what, proportional to the diameter of the balloon. The work done by the gas inside the what, inside the, this one, just wait, what is this inside, just I'm clear, inside the balloon, what is this one is what, balloon, inside the balloon. So try to solve this question. If you are going to a stuck, then let me know. In the next class I will solve this question. Okay, one more thing I want to tell you, for getting a such kinds of question, or important question for gate point of view, I want to suggest you, or it is advisable to all of you to purchase the gate forum test series also. And one more thing, you are going to launch a refresher course. In case of refresher course, what you have to do, actually video lecture will be provided. This will be bilingual. All the gate question from 2019 to 20 will be discussed. All the gate question will be discussed there in this course. This course is refresher course, name is refresher course. And then language will be bilingual, 90 English and Hindi both will be there. So this one you can purchase, and obviously we will get much more benefited through this course. Hopefully we will get. Okay, and if any other query, so So let me know. I will here ready to what help you. Okay, dear friends, thanks to all of you to watching this session. And you can give your more effort, and you can use our test series, which is best for especially designed by the highly qualified faculty. So you can get much more benefited from this test series also. You can join our eGate live class also, and you can purchase our refresher course also, in which in bilingual mode all the lectures will be provided there, and you will get benefited, and all the questions from 2011 to 2020 will be discussed there, so no issue will be there. We will get much more concept, and very details. We have discussed all the concept in this refresher course and e-get online class. And in the test series also, we have given the conceptual question which will be going to come in gate, in coming gate, that means gate 2021. Okay. हेलो सर, फिनिश करते हैं सेशन को। मैं कर दूं ऐड अपने तरफ से, स्टॉप से ऐड।